Modern medicine offers two dominant tools for lowering blood sugar: insulin injections and glucose-lowering medications. Today's video introduces a third pathway that requires no prescription, no needle, and no pharmacy. It requires only one thing: contracting the muscles of your thighs. This is not a metaphor. When the large muscles of the lower body contract under load, they release a family of hormonal signaling molecules called myokines into the bloodstream. These myokines activate an insulin-independent glucose uptake pathway, directly pulling sugar out of the blood and into the muscle cells. For anyone managing blood sugar, dealing with prediabetes, or simply watching the metabolic changes that come with aging, understanding myokines may be the most actionable health insight you encounter this year. The thighs contain the largest muscle group in the human body. The quadriceps, hamstrings, and gluteal muscles together account for more than 40% of total skeletal muscle mass. For most of the 20th century, this tissue was viewed purely as a mechanical structure for locomotion. That view was overturned by research from the early 2000s onward, which established that skeletal muscle is an endocrine organ. When muscle fibers contract, they synthesize and secrete signaling proteins into the bloodstream. These are myokines. The prefix myo comes from the Greek for muscle, and kine refers to signaling molecules. To date, researchers have identified hundreds of distinct myokines, and the best studied among them directly regulate blood glucose, protect neurons, suppress tumor growth, and counteract chronic inflammation. The most intensively researched myokine is irisin, first identified and named in a landmark 2012 study, published in a major scientific journal. Irisin is cleaved from a membrane protein called FNDC5 when muscle fibers contract, and it is released directly into circulation. Irisin has two primary metabolic functions. The first is the conversion of white adipose tissue into brown adipose tissue. White fat stores energy passively, while brown fat burns energy to generate heat. By driving this conversion, irisin raises resting metabolic rate and reduces total body fat. The second function is the direct improvement of insulin resistance. Multiple peer-reviewed studies have confirmed that circulating irisin levels are inversely correlated with body mass index and insulin resistance in both healthy individuals and those with obesity. As muscle mass declines and irisin levels fall with age, insulin resistance climbs and chronic blood sugar elevation follows. The causal arrow points in both directions. Less muscle means less irisin means worse blood sugar control. The second critical myokine is interleukin-6, or IL-6. In the immune context, IL-6 is associated with inflammation, but muscle-derived IL-6 released during exercise operates through an entirely different signaling pathway and produces anti-inflammatory effects. Exercise-derived IL-6 enhances glucose uptake in muscle tissue, signals the liver to reduce glucose output, and increases fatty acid oxidation. It exerts an insulin-like effect on glucose metabolism, making it one of the most powerful natural blood sugar-lowering agents the body can produce. The third major myokine is brain-derived neurotrophic factor, or BDNF. Although BDNF is widely associated with brain function, skeletal muscle produces and releases it as well, and it crosses the blood-brain barrier to act directly on neurons. Exercise-induced BDNF stimulates the growth of new neurons in the hippocampus, strengthens synaptic connections, and protects against the brain atrophy associated with aging. A systematic review published in an aging neuroscience journal confirmed that aerobic exercise-mediated irisin release reduces neuroinflammation, inhibits microglial overactivation, and suppresses neuronal apoptosis, all of which are relevant to slowing Alzheimer's disease progression. Beyond these signaling benefits, skeletal muscle employs a second, completely independent mechanism for lowering blood sugar. Inside muscle cells sits a glucose transporter protein called GLUT4. Under normal conditions, GLUT4 remains inside the cell, and only migrates to the cell surface when called there by insulin, at which point it opens a channel for blood glucose to enter the cell. The discovery that transformed exercise science is this: when a muscle fiber contracts, GLUT4 moves to the cell surface and absorbs glucose without waiting for insulin at all. Research published in a physiology journal quantified this effect. Actively contracting muscles absorb glucose at 50 to 100 times the rate of resting muscles, regardless of insulin levels. This insulin-independent glucose uptake pathway is the mechanism behind the well-known observation that a walk after a meal lowers blood sugar faster than any supplement. Furthermore, resistance training over weeks and months increases the total expression of GLUT4 in muscle tissue, meaning that even at rest, trained muscles have greater capacity for glucose uptake than untrained ones. The clinical numbers make the stakes undeniable. A study conducted on Korean adults by a research team at a leading public health institution found that each 1 centimeter reduction in thigh circumference was associated with an 8.3% increase in diabetes risk for men and a 9.6% increase for women. Men with a thigh circumference below 43 centimeters had 4 times the diabetes risk compared to men with a circumference of 60 centimeters. A meta-analysis published in a peer-reviewed journal found that patients with both type 2 diabetes and sarcopenia had a 1.72-fold higher risk of all-cause mortality than diabetic patients with adequate muscle mass. A separate study confirmed that low muscle mass in diabetes patients was linked to a 2-fold increase in cardiovascular mortality. A 16-week resistance training study in newly diagnosed elderly male diabetic patients showed a 46.3% improvement in insulin sensitivity, a 7.1% reduction in fasting blood glucose, and significant reductions in abdominal fat. These are not small effects. These are changes that rival what many glucose-lowering medications achieve. The anti-cancer implications of Myokine add yet another layer of importance. A systematic review published in Frontiers in Sports and Active Living confirmed that exercise reduces circulating levels of inflammatory biomarkers, including C-reactive protein and tumor necrosis factor alpha, and modulates immune cell infiltration in the tumor microenvironment. Irisin specifically has been shown to potently suppress tumor proliferation, invasion, and growth in glioma cells. Researchers from a leading exercise medicine research institute demonstrated that Myokine released during exercise can actively target and suppress tumor cells in circulation. For cancer prevention and as an adjunct to cancer treatment, exercise-induced myokine release is emerging as one of the most compelling biological mechanisms identified in recent decades. Several safety considerations must be addressed clearly. Anyone currently taking insulin or oral glucose-lowering medications must consult their physician before significantly increasing exercise intensity, as exercise can lower blood sugar substantially and the combination with medication may cause hypoglycemia. Always check blood glucose before exercising if you are on insulin therapy and have a fast-acting carbohydrate available. Individuals with knee osteoarthritis or hip joint disease should substitute seated leg raises, water-based exercise, or low-impact walking for squats, as joint loading movements must be modified to avoid exacerbating pain. Those with cardiovascular disease should start at a very low intensity and progress over several weeks under medical guidance, rather than beginning with high repetition resistance training. Nothing in this video constitutes medical advice, and all exercise plans should be discussed with a qualified healthcare provider before initiation. Your thighs are the most powerful metabolic engine in your body. Every time they contract under meaningful load, they pump a dose of irisin, IL-6, BDNF, and IGF-1 into your bloodstream. Hormones that lower blood sugar without insulin protect your brain from degeneration, suppress the environment that allows tumors to grow, and rebuild the very muscle tissue that produces them in a regenerative cycle. This cycle costs nothing to run. It does not require a gym membership, a supplement stack, or a prescription. It requires only the willingness to stand up, bend your knees, and push back up 20 times after every meal, every day. If this video gave you something you will actually use, please subscribe, press the like button, and share it with someone managing blood sugar or worried about losing muscle as they age. Leave a comment below telling us your current squat Counter your blood sugar readings before and after starting this routine. More science-backed content is on the way. Start with 20 squats right now. Your muscles are waiting to be reminded of what they can do.